Okay, today we will solve exponential equations using common logs. Wait, what? What does that mean? What does that look like? So we learned a couple days ago that we could solve exponential equations if we could just somehow magically rewrite them in same base. But when I look at 6, I look at 104, they have nothing in common. There's nothing I can do to rewrite them in base 6 or rewrite them in base 104. No, that's a no-go. We can't do it. So you have to use common logs to do that. In order for it to do that, you just need to multiply both sides by common log. So log base, the default is going to be 10. Just that's what common log is. So log of 6 to the power of x equals log of 104. Okay? Now we will apply the property here. So x will go in the front, multiplying. So x log of 6 equals log of 104. Now, you look at log of 6 as if it was any other number. So you're isolating x, so you divide both sides by log of 6. Divide both sides by log of 6. This is 1. X equals log of 104 over log of 6. Now, you will leave your answer like this if you're not rounding. But now, if the question is asking for an approximate number, you have to put that in the calculator. The way you're going to do that, you can go pull up a fraction bar there, and you're going to go log, that's this button right there, that button right there, log. So log of 104 divided by log of 6. And let's round to the third decimal place. So x equals 2.592. So this is the main idea. Same thing here. Start out by multiplying both sides by log, common log. So log of 2 with the exponent of 3x minus 3. So log of 9. Now, this is your exponent, and that will go in the front, multiplying. So we're applying the power property right here. So 3x minus 3 times log of 2 equals log of 9. Okay, now what? Notice that I put parentheses around here so I don't get lost. So divide both sides by log of 2. This is 1. So 3x minus 3 equals log of 9 over log of 2. Okay, I still need to deal with this because I'm still isolating x. So you have to add 3 to both sides. So here I have 0. I have 3x. So log of 9 over log of 2 plus 3. Now it's easy. Now you just divide both sides by 3. So divide by 3. Divide by 3. Both sides. That means you're dividing everybody by 3. So x equals. So when I'm dividing log of 9 divided by log of 2, I divide that by 3. It's the same thing as if I multiply by 1 over 3. So the way you can look at this is the 3 goes in the denominator. But because you're dividing everybody, both terms, this term and this term, 3 divided by 3 is 1. Okay, watch out for that. Now you're going to leave your answer like this if you're not rounding, but if you are rounding, you have to punch this in the calculator. So log of 9 over 3 log of 2 plus 1. So let's use 3 decimal places here. So 2.057. This one we're rounding. This one is the exact answer. Couple more. Now, one thing, we cannot multiply both sides before the term that contains the x is isolated. So before I can multiply both sides, I need to subtract 3 from both sides here, because this term needs to be all by itself. Okay? So -3, so -3 on both sides. That will leave us with 2 equals 9 to the power of 2x. Now at this point, it looks very similar to what we did on number 1. Okay? Because number 1 was simple. I was just introducing the idea. But number 3, we have to make that just like number 1. Okay, so multiply both sides by common log. We will apply the power property to where the exponent goes in the front multiplying. Divide both sides by log of 9. This is 1. So log of 2 over log of 9 equals 2x. Now you have to divide both sides by 2, just like we did in example 2. So divide both sides by 2. That means, I'm going to write it over here. That's such a pretty arrow right there. Yep. Okay, so that means x equals log of 2 over, remember we divided both sides by 2, so I have 2 log of 9. Okay? Again, if you're leaving your answer in the exact responses like this, if not, put in the calculator, round it to 3 decimal places. One more. Okay, so now I have this whole thing. We're still following the same idea. The term contained in the exponent is already isolated, so I can just go ahead and multiply both sides by common log. So I have log of 7 to the power of 4x plus 1 equals log of 9. Okay? Power property right here, to where the exponent goes in the front multiplying. So I have 4x plus 1 log of 7 equals log of 9. Divide. I have 4x plus 1 equals log of 9 over log of 7. Okay, minus 1, just like what we did in example 2. So minus 1 on both sides. That leaves us with 4x equals log of 9 over log of 7 minus 1. Divide by 4. Divide by 4. Divide both sides by 4. And by both sides, I mean this guy and this guy. So log base 9, log base 10, or common log, or log of 9, 4, because I'm dividing by 4, log of 7 minus 1 divided by 4, 1/4. And you're going to leave your response like that. Or if it's decimal place, if it's decimals, you're going to round it to 3 decimal places. I will see you next time.